Now we're going to build on what we just learned and connect it with something familiar, the power rule. So far, we have used the power rule mostly with integer exponents. But the good news is the power rule also works for rational exponents. That means if we have something like x raised to 1 over n power, then its derivative is 1 over n times x to 1 over n minus 1. And if we have something like x raised to m over n power, then the derivative is m over n times x raised to m over n minus 1. So really, nothing new is happening here. We are just applying the same power rule, even when the exponent is a fraction. Now, let's apply this to an example. We want to find the derivative of s of t equals square root of 2t plus 1. First, rewrite the square root as a power. So s of t is 2t plus 1 to the 1 half. Step 2, we need to differentiate s of t. S of t is 2t plus 1 to the 1 half power. This is a composite function. The outer layer is the power function, and the inner layer is 2t plus 1. So we need to use the chain rule. First, we need to take the derivative of the outer function. We use the power rule. We bring 1 half down as the coefficient and subtract 1 from the exponent. This is the derivative of the outer function. Now, we need to multiply this by the derivative of the inner function, which is the derivative of 2t plus 1. The derivative of 2t plus 1 is 2. One half minus 1 is negative 1 half. So s prime of t is 1 half times 2t plus 1 raised to negative 1 half multiplied by 2. Now we need to simplify this. 1 half times 2 is 1. So s prime of t equals 2t plus 1 to the negative 1 half. If the question only asks for the derivative, this answer is acceptable. But sometimes they ask for non-negative exponent and non-fraction exponent. If that's the case, then you have to rewrite this. 2t plus 1 to the negative 1 half. That means this belongs to the denominator. So I have 1 over 2t plus 1 to the 1 half. And 2t plus 1 to the 1 half equals square root of 2t plus 1. So s prime of t is 1 over square root of 2t plus 1.